taking time, but meanwhile we can see here it is. Yesterday we discussed about a IP address. What is a IP address? It is a logical address uniquely identify a device in the network. You have a devices in the network, you want to identify each device uniquely. So then we use an IP address. Example is like this. Okay, it is like a flat numbers or a roll numbers we'll define, right? First floor 101, 102, 103, 104. Second floor 201, 202, 203. Like this. Floor number, area numbers, or you can say roll numbers. So this is yesterday example is roll numbers 401, 402, 403, 404, 405, 303. So it's different from our part. It's look like a same, but it is different because it's a different one. So it is different network like that we can able to think. So here it is. Each device we assign an IP address in a particular sequence like 1, 2, 3, 4 kind of stuff. So remember always IP address is not a unique address. Unique address is MAC address. Again, IP address and MAC address differences. What is the IP address and MAC address differences? That is also we can, if you want, I will add those information here. Better to add that information because it's a very simple questions. Sometimes it is IP address, MAC address. So guys, already I told how to learn something like it is, what it is, differences, how it works. So what it is, how it is works, and differences. This is the thing. So this here it is. We go with the differences. First one, IP address is a logical address. Actually, this much not required, but I am telling because it's a very simple question. Physical, yeah, it's a physical address. IP address is a logical address, physical address. Okay. One second, one second. One second. Okay. Guys, logical address and physical address. Any other differences? Can be able to change. Cannot change. Cannot change the MAC address. You can't change the MAC address. It's a logical address. There is a private IP address, public IP address is also there. Okay. Private and public IP address is there. Here it is. No private, no public. It is a fixed. Used for communication we don't use to communicate. Don't use to communicate. Okay, like that. So you can find a few for differences. This is represent hexadecimal. MAC address is 12 hexadecimal. This is a 32-bit number. 32-bit. IPv4 32-bit. Two versions are there. IPv4 32-bit and IPv6. How many bits? How many bits? 128 bit. So MAC address. So not two versions, right? It is how many bits? 48 bits represented in 12 hexa. Represented in 12 hexa, like that. So what are the differences you found about IP address and MAC address, domain and workgroup? Like that, you can able to add it. Okay, so everybody is silent. Again, also we discussed about IPv4 and IPv6, 32-bit, 128-bit, and it is 2 to the power of 32, 4.3 billion. It's a 2 to the power of 128 for 3.4 billion. Billions of IP address are a 3.4 into 10 to the power of 38. IPv4 represented in decimal format, IPv6 represented in hexadecimal format. Okay, so here it is. One single IPv4 is divided, 32-bit is divided into 4 parts. So each part we call it as a octet and it is divided by dot. And a hexad is in IPv6, the each part we call it as a block. Each block contains 4 hexadecimal numbers. Each block contains 4 hexadecimal numbers. Totally 8 blocks are there. These 8 blocks are separated with a colon. Okay, colon. So one hexadecimal is equal to 4-bit number. So this is a totally, it is like here it is 32 hexadecimals are there totally. Okay, 32 hexadecimal are there divided into 8 blocks. So each block contains 4 hexadecimals. So in the IPv4 mainly important is, so each octet is a 8 bits are there. Each octet is 8 bits are there. So then 4 octets means 4 8 bits. So it is a 32 bit. So 2 to the power of 8 is a 256 means 0 to 255. Each octet range is from 0 to 255. So here it is the first one, we call it as the first octet, second one is second octet, third octet and fourth octet. So you can also write in any ABCD manner also, no problem. That is depends upon you how you will learn. Okay. Next one is okay. So it is next one is like each octet should not be crossed more than 255. So it's 0 to 255. And your IP addresses, starting IP address is started with 0.0.0 and ending is 255.255.255.255. And this total IP addresses from this entire range is divided into classes. Okay, this entire range is divided into classes. Okay, so there is a 5 classes. The entire IP address range is divided into 5 classes. Class A, Class B, Class C, Class D, and Class E. Okay, so how to recognize any IP address, which class it is based on the first octet only. We should look at the first octet to recognize which class it is. Of course, you have to check all octets. So no single octet is crossed the more than 255. That is the first rule. Second one is to understand which class it is. Check at the first octet and see the range. So here it is a class A 0 to 127. It is also in a certain textbooks. It shows 1 to 126. Okay, class B is 128 to 191, and class C is 192 to 223, and class D is 224 to 239. It is a multicast address, and class E is 240 to 255. One second. Okay, it is. These are the five uh, what we can see. It's a five classes are divided into five: class A, class B, class C, class D, class E. Okay, so class E is R&D, class C is multicast. So class A, class B, class C is a unicast. So someone asked me yesterday, what is a multicast? What is unicast? So I said one to one. But exactly what is the meaning of one to one is understand like this. Yes. It's a picture or anything it is? It is a picture. Okay, no problem. So I need to draw on it something like this. For example, guys, what is someone send a message? Yeah, MAC address is just for identification and verification. So like both are communicate. So there is a certain security reasons also there. Okay. So yeah, right, very good. So when I'm trying to communicate from A to B, so I'm sending like a ping from A to B. So means ping 192.168.1.102. That is called unicast. And maybe I will communicate from C to D. C to D. It is also unicast. For example, A to D. What happened here? A to D. I am trying to send a packet to from A to D communication. It is also unicast. Means one-to-one communication. One-to-one communication. So look at here. For example, here is Adarsh is there. Adarsh, when I'm trying to talk like I ask a question. Adarsh, what is MAC address? Or Amarjit, what is MAC address? So like that, if I ask that question, means it is unicast. I am particularly addressing someone, only one. So that is called a unicast. What is multicast addressing? What is multicast addressing? Just for example, think like that. I have a server. Okay. Through this server, I want to deploy some application or an operating system. I want to install OS in these PCs. I want to install operating system in these PCs. I want to install operating system in these PCs. Now what I have to do it? So this is, for example, this is my WDS server. Means Windows deployment server. Windows deployment server. So I deploy operating system from here for 4 systems at a time. For 4 systems at a time. One. To see what happened. It is not making easy. So I am copying, not copying it is, I am deploying operating system to 4 systems at a time with a single multicast address. So each PC will identify with a unicast address, but all PCs all together the protocol like a boot P protocol they use it. It identify all these PCs are required deployment. So it use multicast addressing. It use multicast addressing. If you don't understand, it is okay because again it is an entire new concept. But try to understand what is unicast and multicast part. So one-to-one communication unicast. So our class A, class B, and class C are a unicast IP addresses. Means if you are using a class A IP address, you can communicate to one PC type only. You want to communicate to multiple PCs, then we have to use for that protocol we have to use um, multicast IP address. So where I have written here it is. This is an example for any cast part, but when you see it is a one-to-one. Okay, so one-to-many used by services, not by us. Used by some services, we can say protocols. Example bootp through DHCP bootp RIP version 2 routing protocols EIGRP OSPF uses multicast multicast multicasting. Okay, that's it. Okay. Next guys, yesterday we discussed so class A, class B, class C. Only these IP addresses are we used to communicate or assign to the devices. So look at here, I have a PCs. I will assign the IP address from class A or class B or class C. Except few IP addresses we don't use it. Example 127.0.0.1 and 0.0.0.0 and 127 series and 0 series we don't use it for a network communication. Somewhere I may written that one, so or not. Yeah, here it is, I've written. So 0.0.0.0 is a reserved IP address, and this is also reserved IP address. 127 is also a reserved IP address for a local host. For local host address, local host or a loopback address. Loopback word we will use it for a testing purpose. Local host is the word we're using for in telling this is my host, and also we don't use 127.0.127 or that series entire series we don't use it. Okay, and also we don't assign 169.254. If in case any adapter is showing 169.254, it is API address, meaning is error. I will explain what is API address. We'll came back to the ranges, guys. Here it is. Last class, last I told this is right. Class A 0 to 127 if you take a class A IP address, if you take any class A IP address, okay, the first two parts are, first part is network portion and remaining are host portions. And this is the default gateway of a class A, and this is the number of PCs in the single network. So example, we can go through example. So I have a 100 dot 10 dot 2 dot 3. So what is this? This is my, which class it is? Class A. So you know what is the network portion is 100. Your network portion is 100 only, and the host portion are, first is 10, 20, 10 dot 20 dot 3 is your host portion. Guys, remember these rules when I will tell this. It is, here it is, 150 dot 50 10 dot 2 dot 190. Which class it is? Class B. The network portion is 150 dot 10. Class B. First two portions are network portions, and the host portion, is 2 dot 190. Okay. So and 201 dot 2 dot 100 dot 250. Which class it is? Class C. Dot 1 dot 2 dot 100 is a network portion, and a host portion will be only 250. Okay. So the network portion and host portion is changes. Okay. Network portion and host portions is a network portion, and host portion will changes according to the class range. Okay. So I will give you one understand, guys, up to here at least. Up to now I repeated what I told, but I understand this example. Now one is talking. So when I say about a logical addressing, I said about a roll numbers, Are you able to hear my voice now? Can you able to
Yes,
see
sir.
my screen?
Yes.
Screen is visible, right?
Yes,
I
sir.
connected
Yes.
with my mobile hotspot. If in case again power cut is happened today, only it is happening like this. It's because it's a small column is there here to understand. So very simplest topic to understand. Small column is lot of people we give a details but they don't understand what. Okay. So but, some message. Very good. Okay. So here it is. When you look at the class, which when you look at the IP address, when you identify which class it is, also identify network and host portion. Then we have to write the rules here. Two important rules. The first very important rule is, okay, if so devices must be in same network to communicate each other. Communicate each other. So I have devices are connected physically, but the logical address also must be in the same network. Look at here, it is 192.168.1.101. 192 means it is a class C. So first three portions are a network portions. First three must be same, right? So can you see first three are same, first three same, first three same. The fourth one is host portion. Automatically it will changes 101, 102, 103, 123 or here 137. So what is happening here? They can able to communicate each other because their network portion is same. So to how to check this one, device must be in the same network to communicate each other means how to check the network thing. So devices network portion must be same. You can say that one also. Network portion must be same network portion. They must maintain same network portion. Their network portion must be same, or we can say their network ID must be same. Next, if you want make communication between two different or or different two or more different networks means their network ID is different each other, different to each other. Both network IDs are different to each other. You have to use router. Why router? It is a inter networking device. Okay? You must use inter networking device. Somewhere in a starting only I put this diagram, right? This is the router. This is one network, one logical network. Of course, physically also different network. Physically or logically different network. This is another network. This is another network. You want to make a communication between them, you need a inter-networking device. It's nothing but a router. Okay. So guys, this is the rule. So you want to make a communication between two devices. So their ID, their ID must be their network ID must be same. Look at here it is. For example, I have a computer like a PC1. Okay, I have a PC1. I configured my PC1 with the 192.168.10.230. PC2 192.16.100.12. These two PCs will communicate each other or not. First of all, which class
Yes.
it is? Very good.
Class.
Class B. Very good. First of all, it is understand it is class B. So only one example. Next example I will tell here. First of all, it is a class B. We identify class B network and host portions. First to our network portion and first to our network and next to host portions. So where is the network portion? It is this is network portion. So the network portion is for both the thing is 127, sorry 172 and 16. That's it. You can say both will communicate each other. Communicate each other. Next one more example, like a reverse example. PC1, same 172, 16, 134. Sorry, PC3, PC4, 172, 6, 17, 10, 165. Okay, now again it is become smaller. Okay, so look here. So PC1, PC2, PC3 will communicate each other. Why not PC4? PC4 network ID is different 172.17. So here it is. This here it is. We got a problem. So it is a 17. So different from others. Okay, this is 172.16, 172.16, 172.16. So here is the statement I am writing here. The statement is PC1, PC2, PC3 will communicate each other and PC4 not. It is out. It is outside of the network. So a simple number will change the network. So that is the thing. Okay, guys, understand. You can able to understand very easily by taking 2 or 3. For example, you have taken a class C. You have taken a class C. Compare first 3 portions. First 3 portions must be same. Not a second portion, not a first portion. First 3 portions must be same. Class B, first 2 portions must be same. Class A, first portion must be same. Look at here. This is class A, right? This class A. Both will communicate each other. Both will communicate each other. For example, this is APC, this is BPC. Both will communicate each other. This is CPC. It is 100, 10 to 66. No, it won't communicate. It don't communicate with the AB. Don't communicate with the AB. AB will communicate each other, but it won't communicate. Why it is not communicating? Because it's a different from this thing. So check the first portion. The first portion is different. So obviously it is different network. So same thing again. APC, BPC. First we'll take class B example I told. So then I tell about a class C example. So here it is a 201, 10, 10, 2. Otherwise I put 100, 2, anything, no problem. So here it is a 201, 100, 10, 3. So AB communicate each other. Now I have another computer C. I put a 201, 100, 11, 4. No communication because first three portions. Class D, for example, you taken a 201, 100, 101, 10, 5. No communication. Not one. Sorry. 200, 100, 10, 6. It is also won't communicate each other. It is also won't communicate each other. How it is won't communicate each other? Always check the first three portions. Always check the first three portions must be same. So then they will communicate each other. It is a class C. So first three portions must be same. Now can you see
Sir,
here it is. Yeah, tell me, tell me.
sir, this is about the communication or the networking within the class. What if class A wants to communicate with class B? Is it possible?
And they won't communicate each other. Very good question.
Okay.
Very good, very good. Okay. So a good question it is. If I have taken one class A, one is from here like this, another is like this. Okay, this IP and this PC. It's a computer. So think like this. This is a computer. Okay. So here it is. Class A I configured here. Class B I configured here. So they won't communicate each other. So that is the rule. So what is the rule? Network ID must be same. Whether it is same class or different class. Different class, definitely we can understand. Same class confusion will be there. Different classes, no problem. See, here it is a small confusion. If I said this IP and this IP both are different, look like different, they won't communicate each other. But if you see, look at here, so it will communicate these two are communicate each other. This won't communicate to this one. Okay. This is
Yes,
also
sir.
look like same, but they won't communicate each other. Okay. So this is more dangerous. It is 16, 17. You know, most of my students will do mistakes. Means not online way, because online way we don't know what happening. Okay. Offline itself. So what people will do? So they'll wrongly enter the things. This is the best example. Wrong entering IP address. It is generally 172.16 will be there. So what they will do 172.16, or they use 190, 168, 10.11 like this, or 192, 168 like this. So instead of putting like this, they will put like this. Or instead of putting like this, 172, 16, 10.11. Instead of putting this one, they'll put it because it is no our way of learning Hindi type means like if okay, this is we cannot write here anything here, right? Something is there like this. I didn't remember. Okay. Because we study Hindi for 3 years only. So there may be a dot or may not be a dot. Okay, so what we will do, so we don't know exactly because we need a mark, so then that may not be there. So we'll put a dot. It's look like a little bit a distance dot. The dot will be little distance. Small dot, I will put it. So then it's look like a dot will be there or may not be there. So it is can be escape, right? That's like that. People are do either mistake or maybe they want to make it little correct. So instead of entering like this, they will enter like this or they will enter like this. Instead of entering like this, they will enter like this sometimes because they remember 172, they want to enter 172, but meantime 168 came into mind. So because of lack of practice and other things. So it is a completely out of session type. Okay. So when you do mistakes, what to do? How to make a C to connect A and B? How to make a how to make C communicate with A and B? Where is the problem? Instead of 100, I can put 101, 100, 2, 66. See, it is simply I change it so C can able to communicate. Same goes for here also. Take it. Where is the IP address? Where is the issue is there? So cross check it. So then resolve it. Make it as a 10. Make it as a 100. Make it as a 201. Okay. So what are the thing? First three portions must be same in a class C. First portion must be same for all devices. All devices in the network. So then they will communicate each other. In a class B, first two portions must be same for all devices. So then they will communicate each other. And there is a very good question. It is if one PC having a one class and another PC having a different class, what will happen? They won't communicate each other. So how? Because this is the rule. Devices must be in the same network to communicate each other. The network portion must be same. Of course, you have a this class and this class are having different network versions. And I've written about network ID, how to find this network ID and all. Will write here.
There
A
is
small
no
part and I will give you a break. Yeah, tell me.
there is no IP change in case of C, then there is no internet working possible.
Tell me again once again.
Sir, in case of C, as you have written, A and B are having the same class A ID, okay, and C is
Okay.
having the different ID. And if we don't change the IP address of C, that internet working is possible.
Uh, okay. One second. I will explain. Yeah, we have a PCs. I got it. So actually, I should not give an example like a ABCD because it confuse between the classes. Okay. So, but I given, but luckily you didn't confuse it. That is a good thing. So it's a PCA, PCB, PCC. PCA, PCB having a same network ID. Okay, so like that is an example I given, right? For example, it is 10 dot 1 dot 1 dot 1 or maybe a 10. This is 10 dot 1.1.11. So when you are trying to ping from A to B, A to B communication will be there. Their network portion is same. So logically, so in generally, they will communicate each other. For example, this is different network. Okay, or maybe like this. It is 11 is here, so it is automatically a different network. Or maybe you use here it is 192.168. Like a 1.110, or maybe use some different network. So what happened? A to B communication will be there, but A to B won't communicate it to C. So AB cannot communicate it to C because of either if you are using like this, different network. If you are using like this, different network. If you are using like this, it is also different network 172.
Sir,
Okay.
with the help of router, is it possible to communicate?
Yeah, very good. If in case you want to keep this IP address like this only, you don't want to change. Normally, as I said, as per your network, you have to change this IP address. If you put it like this 10.1.1.12, it may communicate, or you can use 10.10.1.150. It will communicate, no problem, because important is this one. If in case, okay, first of all, if all are in a same network, physically there are in a same network, right? So physically they are in the same network. Better to change the IP address. Better to change the class C IP address. If in case you still want to use this one only, if still you want to use, I will go back up to here. Very good. I'll remove this one also. Make it much easier purpose. So this is different network. This is different network. Still you want to make a communication between A to B. So AB should be communicated to C. Here it is. You have to implement a router. So this is a switch. It's connected to AB, and this network is connected to router, and router is connected to C either directly or maybe through switch. It will connect. So the router make a communication between these two networks. Or you can use software bridges. Okay, means it is a server. Inside a server, you have to configure routing concept. You have to configure routing concept using bridging technique. Put a two N.H.Hs. One N.H.H is connected to this. Another N.H.H is connected to this. Okay, like this also you have to route it. Compulsory you have to tell how to communicate to this one. Okay. There is a lot of implementation is there. Different ways to implement to communicate, but direct communication is not there. Okay, so this is what I'm trying to explain. So check the both networks. Network must be same. If network is different, try to change the IP address if all the PCs are in the same network, same physical network. If there are not in a physical network, so then you can implement a routing concept to make a communication between different networks. That is also a very good question. Okay, so how to make a communication between different IP addresses? Yeah, here it is. I hope you got it. Already given default subnet mask. Okay, so what is the use of this subnet mask? Subnet mask tells what is your network ID? What is subnet mask? Simply can tells what is your network ID. Network ID. Okay, that's the first point. That is the second point. Subnet mask divide divide IP address into network portion and host portion. Divide IP address into network portion and host portion. Subnet mask use NAND gate truth table. Okay, so NAND operation, this is called a NAND operation. It is a logical operation, and or not like that. It is a NAND operation. NAND operation it is. It's opposite to AND. No. Sorry. Not NAND. Not NAND. AND operation only. It do AND operation, not NAND operation. NAND is opposite to AND, right? So then it is reverse. Sorry, AND operation. AND operation. Okay, that is more than enough. Okay. So what are the default subnet masks? Guys, look at here. For if you are using class A default subnet mask is, remember, where is network portion that is become 255. I am not going much depth of now. So now only I realize you don't want it, right? If you want to go in depth, that is we'll take separately. But here it is. These are the default masks. So one more point I want to add here, that is what is subnetting? It is subnetting. I will add in a separate window. This is a subnet. So here it is. Uh, um, yeah, here it is. Classless. No. Not a classless. I will give you one example, guys. This is my PC1. My PC1. My PC1 IP address is 192.168.10.20. Okay. Now find this network ID. What is the default subnet mask? 255.255.255.0. You know how to convert it. So whether if you don't understand, no problem, guys. It's not a big deal also. Just for PPT only. Just for any, if some people can understand, so they will try. Others don't worry. Of course, I don't want to use the calci for this one because I don't want to put a more time on it also. It is important. So it is programming. Very good. So 192 convert into binary. So this is the binary number of 192. I know already. So then it is next is 168. 168. So here it is 168. There is a dot is there. 10 is 0001010 is a 10. 20 20 is little higher, right? So 001 means it is a 16. 8, 4. This is a 20. Okay, I don't require a calculator, but just for you, I showed it. This is all are ones. 255 means all are ones. Okay, all are ones. Okay, so this is how it will calculate. So 0 1. So remember this table. 1 1 become 1. Okay, actually there is a truth table is there and operation truth table is there. So that is what we have to discuss. So this is end operation truth table and get. If you think if you are not an sir, we are not from the CSE background, we are not from the computer background, we are not in an engineering background kind of stuff. Don't worry, it is a 10th class one. Guys, think like this: A is the input, B is the input, Y is output. Okay, so expression is A dot B, A dot B. Okay, if in case A is 0, B is 0, Y is 1. A is 0, B is 1, Y, sorry, mistake. 0, 0, 0. Okay, 0, 1, 0. A is 1, B is 0, and sorry, sorry, mistake.
So
1,
one
1, 1. This is correct.
1 will be.
Okay, finally it is correct. Okay, so always check comparison. This is AND gate operation. Okay, so look at here in this one. So it is 0, 0, 0, 1. So it is a 0, 0, 1, 0. Like that you have to calculate. Sorry, this is also mistake. This is zeros, 8 zeros because it's a 0, right? So 255 means 8 ones, 0 means 8 zeros. Okay. Now this is how it is works like this. You can go from down like this. So this is the 0, 0, 0, 0. Actually can do it from here, it is might better. 1, 1, 1. 1, 1, 1, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. Dot. Why it is keeping distance? 1, 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1, 0, 1. Sorry. Yeah, 0, 0, 1. That is correct. 1, 0, 1, 0, 1, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1. Okay. Next, this is again 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, again 0, 0, 0, 1, 0, again 0, 0, 0, 0, 0. So you know the what is this value? And if you write 192 dot 168 dot 10 dot 0. So this is our network ID. So what is this? This is the network ID. This is network ID. This is subnet mask. This is IP address. It divides. We got a network ID. Okay. So you have to convert entire thing into the binary, and we can get a network ID. This is simple and straightforward, but there is a lot of ways to get a what is your network ID and so many things are there. So I'm not going to that much part. Okay, so using this AND gate, using this AND gate. So one more part, last part in the IP address is like that, not the last part. There's so many parts are there. So in the because we are in a subnet, so I want to tell about a small thing about a subnet. That's it. I'll give you a break. So please, subnetting. Okay, so any networking little known person also, there is a point is what is subnetting. Okay, subnetting is dividing a network into multiple subnets. Not subnet mask, it is subnetting. Subnets means small networks. Divide a single network, single IP network, into multiple subnets is called a subnetting. Of course, there is another word is also there, that is called a supernet. Okay, supernetting or a supernet. Supernetting or a supernet. It is a combined multiple subnets or networks into a single large network. Don't worry about supernet. It is not even a very important one. It's not a big deal. So that's why we're putting like this. No, not white color. Not a white color. So gray is okay, but this is important. Okay, important is subnetting, is dividing an IP network into multiple networks. So what is the purpose? It is the purpose to save and better utilizing public IP addresses. Utilizing IP addresses or a public IP addresses. I will come back to what is public IP addresses after break. But so what purpose to save and better utilizing public IP address based on number of hosts per subnet or a number of subnets required. Okay, or a number of subnet required. So there is a different way of configuration. Okay, so to achieve subnetting, change subnet mask. Okay, subnet mask. If you use default subnet mask is called a classful network. Okay, if if you use customized subnet mask, it is classless network. Means the class default class will be different. It's a classful network. So I'll give you one example to understand. Look at here, guys. I'm writing a class B 172.16 15, sorry, 10 or 100, whatever it is. So for example, this is my network. Okay, for example, like this is a IP address which is class B. So you tell like this is my IP address. As per the class full, the subnet mask is 255, 250. No need to specify what is the subnet mask. What is the subnet mask? Now, as per this, I am already know. So just try to understand. This is the network ID I am getting. This is the network ID I am getting. If in case same IP, different subnet mask. Okay, different subnet mask. So it is my mind. Okay, so different subnet mask. What happen? The network ID will be different. It is both are look like a same. Both are look like a same, but both won't communicate each other. Both are look like a same, but both won't communicate each other because their network ID is different. So that is also I given earlier, right? So what is that? The network ID must be same. So why? You must know how to calculate the network ID. Then only you can able to do it. So you have to calculate with the subnet mask. Here it is. It is a classful. This is classless. That is one more point. Is here it is. It is a classful. Here it is. Classless. Why classless? I use different network ID. Sorry, I use different subnet mask. Here I use default subnet mask. Here I use different subnet mask. So it is classless. Let's understand classful and classless. And if you change the subnet mask, network ID changes. Okay, so this is how the subnetting will work, but I'm not explaining.
Classless.
You tell me.
Can you repeat this topic again? Classless and classful.
Classful. Okay, good. Good. Okay, here it is. 192.168.10. I said zero network. This is my network. I said this is my network. This is my network ID. Alright, this is my IP address. I like that. So this is my IP address. So how can you? What you will understand? It is. I didn't give you subnet mask. I given this is my IP address. So what you will understand it is. So the subnet mask is by default. Default subnet mask will be applicable. Default subnet mask will applicable. So you use the default subnet mask. The type of network it is classful. Classful. Look at here. ncpa.cpl. This is my VMnet2 details. Right. Go to properties. So I'm going to my IPv4 properties. Like this. I'm assigning an IP address 1 192, 168, 10.10. Say I am going to subnet mask. It appears default subnet mask only. Look at here. I am going to 172, 16, 19, 10. What subnet mask it is appears? Default subnet only 255, 255. You go to the class A. Class A default subnet mask. In case this is called a class full. If in case I change this subnet mask, I change that subnet mask. This is class A, but this subnet mask is not that one. Class A's default. It's not a class A default. It is something different. It is something different than that one. Meaning is it is a classless. It is a classless. Simply to okay. So this is an IP address. I said this is my IP address. So what you will take it? You take what you will understand the subnet mask is automatically the default one. Okay. Just in case. Just in case. I'm using a class B network. Okay. I said my network, my subnet mask is like this. It is a classless. It is a classless. It's a classful and classless. You know, you must tell subnet mask. In this one, you no need to tell subnet mask. In a classful, you no need to tell subnet mask because default is applicable. No need to tell subnet mask because default will take. Okay, we can understand a default one. It's a classful. We are telling it is a classful. If you don't serve a subnet mask, by default it is classful. By default it is classful. But you serve a subnet mask compulsory if it is a classless. If it is classful, default will take. Okay. So in this case, give compulsory subnet mask because it is not classful, it is classless. Okay, so classless we don't know, right? So that's why it is like, you know, instead of writing a subnet mask, I will write like this /24. So what is this slash notation? This is called as slash notation. This is a slash notation to represent subnet mask. To represent subnet mask. Okay. So what is this number? /n. N represent a number of ones in subnet mask or network bits. So ones are so what is this? 24 means 255 means 8 ones, 8 ones, 8 ones, totally 24. Example here it is, look at here 255.0.0.0/8. It is called CIDR method. Find out what is CIDR, classless inter-domain routing. classless inter-domain routing. It represents slash 24 also called as a prefix. Okay, so don't need to confuse from one to another one. Okay, so you don't need to confuse from what is prefix and slash notation. So it is simply, it represent a subnet mask. So guys, not only these subnet mask, also there is a lot of subnet mask are there. For example, this is slash 25 slash 25, like that it will be added. So okay, so this is very easy, but this is 8, 16, 24. But how I got a 25? Because 128 means 7 zeros. It will be added. So to add what it is comes here. So and also then I will give you one table also. You can try that much. Not required. Why I'm teaching also I don't know. Okay. So this is 128. This represent 128 like 16. Like 16. 128 means here it is, one more one is there. Okay, so it's a bit is like that, so we can see. So 11000000 meaning is 192. 111. So there is no gaps in that one in a subnet mask. Okay, so it represents 224. 111. No need to buy hard, just you need to know how to convert binary to decimal. If you know the binary to decimal conversion, all these things are very easy. How to stop these things, because it is again too much for you also. All ones are 255. All zeros, of course, 0. All zeros are zeros. Okay. So here it is. You want to take an example also, we'll take an example. Look at here. This is 255.255.240.0. You know how it is look like 111.111.111.240 is there, no? It means 111.000.000.000. So how many ones are there? 8 plus 8 plus 4. So 20 ones are there. So meaning is slash 20. Okay. So you have a like a 255, 255, 255, 224. So how many ones? All are ones. So again 255, and it is 224. 224 means 111.0 like this. It is first 3 are a 24 plus 3. It's 27. So this is how slash notation will come out. Okay, in case in a future, not now, exactly in a future, this slash notation is also very useful. Okay. Writing an IP address. Again, writing an IP address is also important. So like this. Same this IP address I will write like this 172.16.19.100/24. You can write like this also using a slash notation. Even this is also we can write like this. So 192.168.10.110/24. Okay. So this is /24 saying like a prefix or representing subnet mask. Instead of writing a subnet mask, you can use slash notation. Mainly, if you are using a default subnet mask, so it is a classful network, not required to represent subnet mask. In generally, sometimes you have to represent. Okay. So if you change the subnet mask, it is not a classful, it is a classless subnet mask. Compulsory you have to tell the subnet mask either like this or slash notation. The slash notation also called as EIDR method, classless inter-domain routing, also called as prefix. Number of ones in the subnet mask is slash after number. So slash 24 means 24 numbers. So additional numbers 255 is 8 numbers, but you having additional numbers like this, then compulsory. Okay, compulsory you should know these things. Okay, this is need any prefixing? Yeah, very good. Okay, so I think you are understanding. If you don't get it, no problem, guys. Basics only important. Next one is I will explain about a private IP, public IP address, or OS layer. I will start with OS layer first of all. Basic introduction. Okay. So take a break. I take a lot of time only class. Meanwhile, disconnection. Take small break.